Hi again. We're doing a series on NAT. I've done a static one-to-one NAT, which has this is the demilitarized zone, and it's forwarding just two ports, port 53 via TCP and UDP, and port 80 via TCP. And I've done another video which is just the pool option. So I wanted this series of IPs across this, so 192.168, as a filter and an ACL to use a pool of addresses to go out and come back. And in that video I did say that I would use the option of port address translation, because at the moment we're only using network address translation up to now. So this time we're going to use port address translation. So if you looked at the previous configs in here, we've got a pool in there, we've got the combination NAT command which grabs our pool called NAT pool there and adds it to this access list down here, and those two combined create NAT, which allows these networks down the bottom to run NAT through this router, router 2, and access the internet with a valid IP. So what I'll do is actually just wipe this off. So I'm going to get rid of those two commands there. I want to keep the access list, because what I'm going to do is just use this single IP address on the outside and run all my connections through that. So let's wipe these two commands out and go from there. So conf t, whoops, ni, the Knights of Ni. So no, and I'm a lazy typist, so I'm just going to copy that and paste it there. In use? Oh yeah, okay, cool. Let's delete the other one first, the actual map pool. And then we'll get rid of the other one. Nice. Okay, so if we do show my running config, I still have NAT inside on my gigabit Ethernet, NAT outside on my 01, and inside on my two serials, and we'll need those as well. Down the bottom I've still got my ACL, which is permitting 192.168, so anything that starts with 192.168 will be permitted through this ACL. This is my static NAT to port forward from the outside into my demilitarized zone, so all I need to do is add one new command. So IP NAT inside source is still going to be my list number 1, and now I have the option. So previously I used pool, but now I don't have a pool, so I'm actually just going to use the interface gigabit Ethernet 0/1, and we can actually hit enter there, which will just mean one of these internal hosts can gain access. What I want is everyone on the inside to use this single address on the outside, and I type overload there. So hit enter. Now if I just go back a little bit, and instead of there I had pool, NAT pool, and I overloaded there, then this pool could have actually been overloaded as well. So even though we don't have a pool now, if we did, we could have overloaded that. So let's have a look at what the outcome of this one is. So IPNAT inside source, the list that we're using is list 1, the ACL, and we're just saying use the IP address on this interface and use it for all connections from the inside out. So show IPNAT translations. At the moment we've only got our static ones in there. So let's see if this works. So we're getting a reply from 200.20.22, and let's go and have a look at our translations again. And here's our ICMP has come through. So 200.20.21 is our inside global now. We've pinged 200.20.22, which is our outside local and outside globals, and this is the address that we came from. Let's pop onto this guy over here, and let's ping 200.20.22 again. This time it's working, last time it didn't. Let's have a look at our translations again. So 192.168.10.12 is using 200.20.20.1, and also 192.168.20.31, another inside local, is also using 200.20.21. The differences in the ports, or even though these aren't ports, these numbers for ICMP is what is separating these connections. So when the packets come back, we're going to be using these values to actually determine the best path, and the inside local to actually connect to. So one thing we can do, let's tart this up a little bit. We'll put a server up there, we'll plonk that on there. What we're going to do is chuck the address 200.10.10.10, 200.10.10.1 was our gateway, and 200.20.20.1 was our DNS that we had before. Let's just make sure we can ping things. So that's okay. It is working. Let's run some services. This is a web server. So let's modify it a little bit. Index, let's edit that and change our color to green. And that way we know we've got the correct one out there. So let's pop back onto this PC. And we're not running DNS at the moment. So let's just type in 200.10.10.10, and we've got it, it's green. We've got that up there. So let's do the same for this PC, and 200.20.20, missed it, didn't I? 10.10.10, and the same deal. That's worked. The main thing we want to see is our translations. Show IPNAT translations, and there we have TCP from the 10 network and TCP from the 20 network, working quite happily. So they're using different port numbers to actually differentiate the two connections. That port number is 124, 125 on the inside. Actually this is just about spot on. It's a good little thing there, actually. Normally you don't see that. Okay, this initiated the connection on 1025, and we translated the port number because 1025 was already used. Most times with ports in port address translation, it actually doesn't change the port. It doesn't translate it into a different port, because generally most connections would actually be quite a bit different to the ones we've got there. But in Packet Tracer here it showed us that it actually is working quite nicely. So that's a bit of a bonus. So that's good. And that's it. So let's clear IP NAT translations, and we put our delete everything, a little asterisk there. And if we show IP NAT translations again, then we've only got our statics in there. So we've built quite a comprehensive network in there. Quite nice. So we've got our demilitarized zone. These guys are all running NAT. There's no ACLs running as firewall rules, but there is a single ACL running in there, which we're using for our NAT. So show run. So right down the bottom there's our standard ACL that we've applied to this NAT with our overloading stuff. Okay, one last thing to talk about just before I wander off. I said this was going to be a quick one, but I'm extending it. Investigate the order of operations. So order of operation for a router. The reason I'm putting that in there is when you apply an ACL, access control list, to these interfaces, you have to think about NAT and how NAT is going to be applied. So generally what happens is on an inbound interface, you would have the inbound ACL applied. It will then go into, there's a few other orders, but effectively the routing process happens. Then as it starts to go out, network address translation happens, and then the outbound ACLs would actually happen after NAT. And that implies that when the packets come back, then an inbound ACL on the outside would actually have an effect there. So if we're coming back in, it's the in ACL, then NAT, then routing, then out ACL if there is one. So be careful of that when you're doing your ACLs, and NAT is floating around there as well. Routing, let's call it routing, shall we? So yeah, be careful of that when you're applying ACLs to a NATed router. And that's me for NAT. We've got 3 of them in there, static for our demilitarized zone, a pool which has a whole bunch of different things going on, and overload. The single interface, we didn't create one with overloading a pool, but that step is trivial. You should be able to do that, and you should be able to crank up NAT and be quite happy with it. Thanks for listening again. Cheers.